Okay, here's an ugly equation. We have a new transcendental function in here. He's known as the natural log. So you're going to take the derivative of each of these. So there's 3 derivatives to take. The derivative of the first one, cosine, is negative sine, right? So like if you look at your formulas, the derivative of cosine x is negative sine x. So this one has a 2 in front of it, so that means it's going to be negative 2 sine x. And we have minus. Now the derivative of the natural log of x, the derivative of natural log of x equals 1 over x. And we can find that by using the definition of a derivative, the limit definition. So that means we have a negative 3 multiplying to 1 over x, because the derivative of natural log of x is 1 over x. And so like if we were to simplify this, you just throw the negative 3 on top, but a negative and a negative is a positive. So our final answer would be negative 2 sine x plus 3 over x. Yeah, go ahead. What's your question?
How'd you get a negative 3 that is also subtracted? Because isn't the subtraction making the 3 negative?
Subtraction, yeah, because you can say that's a negative 3, or you can say it's a minus. It doesn't matter. It's just you'll end up with the same result. So because it's a negative 3 and you're multiplying it, wait a second.
Yeah,
I see what you're saying. I see what you're saying.
Can it just be 3?
I just magically said that was a negative 3. What a doofus I was. Okay, so 3. And then you go 1 over x. So yeah, so it stays negative. Woo! Almost messed that one up. Good job, David. All right. Now some of you guys might be wondering, why does he take the derivative of that one? Well, what's the derivative of any constant, my stews?
0.
It's always 0, so we don't need him anymore. All right, look at that, e to the x. E to the x. Okay, first the cosine. We've done a couple of these, so I'm just going to say it's negative sine x. But e to the x, man, that is the only function that does this. Okay, if this is e to the x right here, if I pick a point, guess what the slope is at that point? It is the y value. So whatever the y value is, the slope of this is also that y value, which is weird. Like let's say this is a 3 right here. The y value would be e to the 3rd power, right? Well, the slope would also be e to the 3rd. It's the only function that does that. The rate at which e to the x changes always is itself, which is pretty magical. So it's just 3e to the x.